students. We are going to discuss another JEE Mains question today. This question came this year, and this is a river swimmer problem. So in this question, a swimmer can swim with velocity 12 km per hour in still water. Water flowing in a river has velocity 6 km per hour. The direction with respect to the direction of flow of river water, he should swim in order to reach the point on the other bank just opposite to his starting point. Is in degrees they have asked to the nearest integer. So relative velocity formula is velocity of A with respect to B is equal to velocity of A with respect to C minus velocity of B with respect to C. So in this case, we can write velocity of swimmer with respect to ground is equal to velocity of swimmer with respect to water minus velocity of ground with respect to water. You can modify this formula. Velocity of swimmer with respect to ground is equal to velocity of swimmer with respect to water. And this will be velocity of water with respect to ground. If you have changed the relative, then I'll put a negative sign. So what we're getting is an enhanced formula for this question. Velocity of swimmer with respect to ground is equal to velocity of swimmer with respect to water of course of the river, plus velocity of water with respect to ground. That means these two vectors will add up to give velocity of swimmer with respect to ground. Now, if I have the river looking like this, so to reach in the opposite side, I need the velocity of the swimmer with respect to ground to be perpendicular. This is velocity of swimmer with respect to ground. And the velocity of the swimmer with respect to water that we have to find, and velocity of water with respect to ground, that is of course flowing in the horizontal direction. This is velocity of water with respect to ground. And to this vector, I need to add this vector. Velocity of water with respect to ground is known. The direction is known. To this, I need to add velocity of swimmer with respect to water such that I get this. So from triangle law of addition, adding this vector to another vector such that I get the third vector, that is velocity of swimmer with respect to ground. That should be vertical. That should be along the perpendicular direction to the river. So this is velocity of swimmer with respect to water. And for this triangle, this is a right angle triangle and values are given. Swimmer can swim with velocity 12 km per hour in still water. That means this is velocity of swimmer with respect to water. This side is given to me as 12. And water flowing in a river has velocity 6. So this is given to me as 6. If I want to find this angle theta, so I can write cos theta equals to 6 by 12. That will be equal to half. So here theta is equal to 60 degrees. But in this case, they have asked the direction with respect to direction of flow of river water. Means they have asked this direction with respect to the flow of river water. So to find angle between two vectors, you have to put the tail at the same point. If theta is 60, so this angle we have to find, that will be equal to 120. So the angle that they have asked between the velocity of swimmer with respect to water and velocity of water with respect to ground, that angle will be 120 degree. So here the answer will be 120 in degrees. Answer will be 120. In the next question, this is again asked in this year. A body of mass of 2 kg moves under a force of this much Newton. It starts from rest and was at the origin initially. After 4 seconds, its new coordinates are this much. The value of B is asked. Round off to the nearest integer. So mass is given and force is given. So I can write acceleration vector will be force vector upon mass. So force vector is 2i cap plus 3j cap plus 5k cap. 4 divided by mass is 2 kg. So answer will come in meter per second square. Acceleration vector is I cap plus 3 by 2 j cap plus 5 by 2 k cap. Now to find the displacement, we can use a trick. We can directly write the x, y, and z component individually. So acceleration in x is 1 meter per second square. Acceleration in y is 3 by 2 meter per second square. And acceleration in z is 5 by 2 meter per second square. So it's starting from origin. So we can just use the ut plus half at square. Initial velocity is 0 because it starts from rest. So initial velocity is 0. I can write x is equal to half axt square. Y is equal to half ayt square. And z coordinate will be equal to half az t square. If I put the value, x will be equal to half, acceleration is 1, time is 4 seconds. So 4 into 4, that will come out to be 8. We want the y coordinate, that's the value of p. So half, acceleration of y is 3 by 2 into square of the time, that will be 4 into 4. That will come out to be 12 meter. So 12 meter is our answer. The value of b in meters will be 12. No need to round it off, this will be 12.